Today's lesson is from Unit 5, which can be found in Chapter 9 in your textbook, Lesson 2, Investigation 1 on flowcharts. This flowchart video will help you when you're learning to backtrack in later lessons. Please set up your notebook paper with today's lesson and the date so that you're ready to take notes on the vocabulary and sample questions to help you with this lesson. Today our goal is to create flowcharts to demonstrate the steps that are needed to solve an equation in order. When you're ready, push play on the video so you can take some notes. The first thing that you should be thinking is, what is a flowchart? Well, a flowchart is a type of graphic organizer that shows the steps to complete a process in order. Please take a moment to record that definition to help you. Please notice that the important points are that the graphic organizer shows all of the steps and that it shows them in order. That's really important in math, as you know we've worked with order of operation in a past unit. The flowchart that we're going to be working with are made out of circles and arrows. Each flowchart will have a circle at the beginning and the end. The first circle represents the input. The last circle will represent the output. In our first example, we are going to start with an input, we're going to multiply our input times 4, and then we're going to add 5 to the product. I'm showing that I'm going to start with my input, which is n, by putting n in the first oval. N is my input. In this example, my output will be the showing all of the steps that's happening to my input. So I'm going to have 4n plus 5. Please take a moment to make sure you have all of this copied. In between each of my ovals, you'll find an arrow. Each arrow represents a mathematical operation. Well, on the last slide, you wrote down our mathematical operations. What are we going to do to our input? The first thing we're going to do is multiply it by 4. The next thing we're going to do is add 5 to the sum. Notice that I'm writing those steps above each of the arrows. You should be writing those steps above each arrow as well. You might also notice that there's space in between the circles. That space in between the circles is going to have a third oval. That oval is for the result from the operation on the arrow to the left of it. So you notice that we have n times 4. The next oval will house the result of n times 4. n times 4 equals 4n. So I'm going to record 4n in the second arrow circle. Now that you've recorded the process in your flowchart, please make sure that your notes are all caught up. What is that oval for? The oval to the right of each arrow is the result of a mathematical operation. We can notice again that n times 4, the result was in that next oval, 4n. 4n plus 5, we could find the result in my next oval is 4n plus 5. Okay? The flowchart is going step by step. Each time we have an arrow, we're doing another mathematical operation to whatever was in the previous circle. The best way to practice is to do a few examples. So please copy down this flowchart and let's solve it together. The direction says to complete the flowcharts. Here, I can see the input has been provided for me. I'm going to complete the flowchart to find my output. The first value is given to me, 5. The first operation is times 7. 5 times 7 is 35. So I'm going to put 35 in the next oval. The next operation says minus 3. So I'm going to subtract 3 from 35. (35 minus 3 is 32. My output here is 32. Take a moment to copy that flowchart. Well, now what if we thought of this as an expression? 5 times 7 minus 3. Order of operations would tell us to solve 5 times 7 first. 5 times 7 is 35. We would copy down our minus 3. 35 minus 3 is 31. Notice that I came up with the same output as I did in my flowchart. Please copy down this next example. Notice that this example is a bit longer than the last one. There are more ovals and more arrows. I can have as many arrows and ovals as I need to complete all of the operations or all of the steps to complete my equation. Here, my input is 4. I'm again solving for my output. Let's start with our input and complete each operation to get to our output. 4 divided by 2 equals 2. So I put the quotient in my next oval. 2 times 5 equals 10. So I'll put that product in the next oval. 10 minus 6 equals 4. So I put my quotient in the last oval. 4 is my output. If I were to write this equation, I would have 4 divided by 2 times 5 minus 6. Again, order of operations would tell me to complete division first. 4 divided by 2 equals 2 times 5 minus 6. 2 times 5 is 10 minus 6, and 10 minus 6 would be 4. Again, my output was 4, showing that my following order of operations in the flowchart was successful. But what happens if I have variables? Let's try another example. This example has variables. J equals 7m minus 2. I want to start by making my flowchart. I need to look at how many operations there are. That will tell me how many arrows to draw. There are 2 operations here, multiplication and subtraction. So I've drawn 2 arrows to show the 2 operations. In between each of the arrows, I'm going to fill in my ovals. Now I have an oval before and after each arrow. My input belongs in the first oval, and my output will go in the last oval. My input here is M. My output is J. Here, my output is written by an expression. I'm not going to be able to solve this because I have 2 variables. So let's look at what happens to M. M is being multiplied by 7. 7 times M is represented by 7M. Then 2 is being subtracted from the product of 7 and M. So I'll say 7M minus 2. All I've done is start with my input and then complete each operation to come out with my output. Here my output is an expression. Notice that J is equal to 7M minus 2. Here my output J is equal to 7M minus 2. Here's one last example for us to do together. Again, I need to draw my flowchart, so I'm going to count my operations. I see addition and division. That tells me that I have 2 operations, so I'm going to need 2 arrows. There's always going to be ovals before and after each arrow, so I'm going to have 3 circles or ovals for this example. I'm going to start with my input, and I'm solving for my output. My input here will be the letter A. My output is D. My output here is equal to the phrase that's equivalent, or the expression that's equivalent to D. So let's see what's happening to A. First, A is being divided by 10. Order of operations tells me that division comes first. So we're going to divide by 10. Next, the quotient is being added to 3.2. So I'm going to write plus 3.2. Now I can fill in my middle circle, A divided by 10. Well, I know that I can show that using a fraction bar, A divided by 10. Next, I need to add 3.2 to the quotient of A and 10. So I'll do A divided by 10 plus 3.2. Take a moment to copy this one down, and then I'd like you to try these next ones on your own on a sheet of paper. Okay? The first 2, the flowcharts, are provided for you. I'd like you to complete the flowcharts. The last one's a little more challenging. Notice that there's division in it. Remember that you've just copied down a division example in your notes. Use your notes to help you. Good luck.